Okay. I'm glad to get a chance to chat with you. Again, it was nice to have Mrs. Mueller working in my lab last summer. So I'm going to be talking about one part of what we do in electrical engineering. Electrical engineers are the people who design anything electrical or electronic. So you ever wonder how is this put together? That's what electrical engineers do. Anything, cameras, airplane motors, the electronics that drives your car, your TV, all of that's designed by electrical engineers. So if it's got a battery or a power cord, we're supposed to be the people who knows how it works. It's a lot of fun because you can, at the end of the day, you can put together something, you can say, hey, check this out, this is something that I built, this is awesome. So it's a lot of fun, it's a great field to work in. What I'm going to talk about today is solar power. When people talk about solar power, a lot of times they'll say, oh, solar is just ridiculously expensive, it's not going to ever work out. Most of the time, especially for people who are a generation older than us, they're talking about solar panels that were installed on the roof of the White House by President Carter in 1977. Those panels cost $80 per watt. If you wanted a 100-watt panel, like just enough to drive your laptop, that cost you 80 times 100, which is $8,000 just to power your laptop, okay? I think we could do a little better than that. So solar power panels today are under $1 per watt. So that same panel is going to cost you under $100. So we'll talk about why that's true and and what we do to make it better. So overview today, I'm going to talk very briefly about how solar cells work. The simplest solar cells made out of silicon, like the one I'm going to pass around, and then we'll talk about how we can make solar cells cheaper. So that's because if the main thing that's holding us out from putting solar panels everywhere is their cost. They're still way more expensive than coal, especially because the fact that the sun doesn't shine all the time. So the fact that the sun only shines mostly during the day, and even then you're getting most of the power only when it's close to noon, that's really what's keeping solar power back. So in addition, if we could do something like energy storage, we could capture that energy that's the most energy that's getting to you, which is close to noon, and then use that round the clock. So things like hydropower and batteries. And then we'll talk a little bit about research in solar power, some of the things that make more efficiencies, and I'm going to close with some myths about solar power that you might have heard. So the reason we want energy is because electricity, as a kind of energy transfer, electricity is one of the most useful forms of energy we have. It's way more useful than heat. If you're trying to convert heat to electricity, like burning something, the efficiency to convert it to electricity it's somewhere between 15% and maybe 50% if you're lucky. So a typical, like a coal plant or a nuclear power plant, has efficiencies running between 40 and 50% efficiency. So you're throwing away most of your energy because to get from heat to something useful, because we want to be able to drive our electronics, our computers, our lights, that all requires electricity. Getting from heat or fuels to electricity is really difficult. Solar panels, on the other hand, give you electricity directly, so that they generate one of the most useful forms of energy, of power that we have. And we use that because in places where you have a lot of manufacturing, like in the United States, especially around here, we have a lot of manufacturing plants because we make stuff, and that all requires electricity to be able to drive a factory. We also would like to be able to get off of things like coal. More than half of our power or electricity in Indiana comes from coal. Something like 65% in Indiana, Ohio, Pennsylvania. And so we'd like to be able to get ourselves off of something that's very, very dirty to something that's completely clean. So the reason we like rooftop solar is that rooftop solar, you generate the electricity where you use the electricity. You don't have to transfer the electricity over hundreds or thousands of miles of transmission lines. You're using it right where you're making it. So rooftop solar is the best economic value because what you pay to the power company is the most that electricity is worth anywhere along the chain. Think about how much a farmer gets paid for a pound of wheat versus how much you pay the grocery store for a pound of flour, right? You're paying a lot of money, the farmer gets very little of that money because there's all these middlemen in the middle. So rooftop solar is kind of cutting out all of the middlemen. You're generating the power and you're using the power right where you're generating it. So rooftop solar is a big advantage because it's very democratic. Everybody can put up a solar panel and you get that electricity right where you want to use it. Wind and nuclear, on the other hand, they are competing against big coal plants because in order to make wind feasible, you have to have really big wind towers, which means you're not going to be able to afford $1 million or $10 million wind tower by yourself. So those have to compete with the cost of things like natural gas and crude oil and coal. So it's very difficult to beat those at wholesale prices. Basically what's the cost of the factory or the power plant is getting paid in wholesale prices. At your house, you are paying retail prices. It's the difference between what you're paying to the store, that's retail, and what the store pays to its suppliers, which is wholesale. So solar, you can see, even without subsidies, solar is already competing with retail electricity, especially for places like Hawaii and New Jersey where electricity is really expensive. Solar power is already a big win. So Hawaii, if they want power in Hawaii, they don't have any access to, they have very little hydro, they have almost no access to coal or oil, so they have to ship everything in. So if you want to turn the lights on in Hawaii, you have to ship that coal and oil in. Very expensive. So solar is a huge win in Hawaii because electricity is so expensive. Solar panels are a real win. So the way solar cells work is you take a block of material. So a semiconductor is a special kind of crystal that will conduct electricity at certain temperatures, or if you put certain impurities into it. So things like silicon. Silicon is the best known semiconductor. That's what all of our computer chips are made of. Has all of its atoms lined in rows and columns, and every atom is bonded to 4 other atoms. So you guys will have seen in chemistry classes that atoms want to have 8 outer valence electrons. So each silicon atom contributes 4 electrons, each of the neighbors each contributes an electron, and so every atom is completely bonded to its neighbors, it's stuck in place, every electron is stuck between 2 atoms, everything is happy, until you take a silicon atom out and you replace it with a different kind of atom that might have an extra electron on it, so it might have an extra negative charge, and that becomes a fixed ion in the semiconductor. So in certain places in the semiconductor, you introduce extra negative charge that's stuck. It can't move because it's the atom itself that's got charge on it. Other places you replace it with a positive ion. So basically if you have positive and negative charges, you create an electric field between these two. So now if you start with this material, this is what your semiconductor looks like. The panels that we have on top have a negative, the top, you can't see the ions, they're too small because they're individual atoms. The ions on the top surface of this wafer are negatively charged. On the back surface of the wafer are positively charged. So from front to back in each of these black wafers is one of these combinations of positive and negative charges. So now if we shine light on this, light will excite one of these electrons to an excited energy state where it's free to move through the crystal. And then that also leaves behind a positive charge. So wherever you took the electron out, that bond that was left behind is you have to conserve charge. So if you have a negative charge come out, you must have left a positive charge behind. And we treat that as if it's a particle all by itself. So if any of you guys have ever been in a solid traffic jam, like in Chicago, you know if traffic is just stopped, nothing moves until somebody takes an exit way ahead of you. And then another car moves into that spot, another car moves into that spot, another car moves into that spot. So you can count all 10,000 cars ahead of you, or you can just count the spot. And it's much easier to keep track of one single spot. So that's why we think of the positive charge, even though it's not really a particle, we treat it as if it's a particle because it's a missing electron. So it's got a positive charge and it behaves as if it's moving like an electron. So we have a positive and negative charge. The positive charge is going to be attracted to these fixed negative charges, but this one can move. So it's going to move over. The electron is going to move toward the positive charges, and now if you put metal contacts on the outsides of these, you can extract the positive and negative charges as a useful voltage. This behaves just like a battery. You've got the positive terminal of the battery and the negative terminal of the battery, and you can drive whatever you want. You can drive lights, you can charge it, you could actually charge a battery with this. So this is how solar cells work. This is the principle between all solar cells. They always have some way of separating the electron and the hole, and then once they get out to metal contacts, then you use that to drive electricity. So some of the costs of solar power might be surprising. Up until last year, the major cost of solar power was the solar cell. Not too surprising. You think about, I want to install a bunch of solar cells. This is what I have to go out and buy. Well, it turns out that as of last year, the major costs of solar power are not the cells themselves anymore. Because the cells have gotten so cheap that now we're limited by other things. So solar cells put out DC power. So like a car battery or just any battery puts out a constant voltage. That voltage is constant. So you plug in something into your cigarette lighter, it's 12 volts. Plug in your iPhone or your Galaxy, that's a USB plug at 5 volts. That's a constant DC voltage, DC meaning direct current. So all of our batteries have a positive terminal and a negative terminal. And if you want to get to something useful like an outlet, This is 120 volts of alternating current, or AC, where there's not a positive and negative terminal because it's constantly reversing. 120 times a second, it's going back and forth. The current is going back and forth between the two straight-bladed terminals. So every time you have a solar cell and you want to hook it up to your house, you have to have an inverter. So this is the kind of inverter you would put in your car. You would buy something similar for your solar cell that takes the DC voltage from the solar cell and gives you AC voltage out, and also at different voltages. This one is, I think, an 18-volt solar cell, and you need to produce 120 volts AC. So you have to buy an inverter, which adds to the cost of the system. It's not just the solar cell, you have to buy an inverter also. And then you also have to pay for a building permit. And in the US, in some states especially, the building permits can be $500 to $5,000. In fact, some utilities have asked for $50,000 for an engineering study for the right to put a solar panel on your roof. That doesn't actually buy any solar panels. That's just to pay the utility company for the right to put the solar panels on your roof. So that's ridiculously expensive. Compare that to Germany, which is the hero right now around the world in terms of solar power, where the building permits are basically $50 and it's automatic. You also have installation costs because you have to pay somebody to put it on your roof. You need to hire a roofer, somebody who understands the mechanics of the structure of the roof, to know where the crossbars need to go, and you have to hire electricians to actually wire the things together. So again, you're paying for the installation costs, so that even if the solar panel was free, solar power is not free because you have to buy an inverter, you have to pay for a building permit, and you have to pay for installation and some other things. So the costs of solar are more than just the panel.
Please pardon this interruption. This message is for juniors who have been invited to the award ceremony today. You should now report to the Student Center to check in with your counselor. You will then need to line up in alphabetical order and proceed into the auditorium when directed. You must check in with your counselor or your name will not be called during the ceremony. Thank you.
So there's a couple things that we can do about that. One is to try to make the solar cells even cheaper still. Knowing that we have these other costs, can we make these even cheaper still? So one of my colleagues at Notre Dame, Prashant Kamad, is famous for making really low-cost solar cells, things that you can mix up in a beaker and pour out on a plate over a big sheet of glass. In fact, one of his students made a great YouTube video that if you Google a delicious solar cell technology, he shows how to make an edible solar cell out of powdered donuts and hibiscus tea. So it sounds crazy, but it actually works. You can make an actual working solar cell out of things that you can safely eat. My group takes a different approach. We're going, instead of for the ultra cheap, we're going for the ultra efficient. So try to keep the cost the same, but give you more bang for the buck. So what we do is we stack multiple different solar cells on the same wafer. So instead of having a single wafer of a single material, like silicon, I'll go ahead and pass this one around. What we do in my group is we try to make better efficiency out of each slice of the solar spectrum. So solar, starting from the visible wavelengths out into the infrared, covers everything from blue to green and yellow, orange, red, and the infrared. So the solar spectrum is really bright. The sun emits at a lot of different colors, and it's really difficult to make efficient use out of all of those colors separately. So what we do is we design a separate solar cell for every color. So we have one that absorbs the blue and green, another that absorbs the orange and yellow and red, and then another that absorbs the infrared. And so by stacking these, since each individual cell only has to use a little slice of the solar spectrum, only a narrow range of colors, it's easier to make that more efficient. So each cell by itself is efficient. So if you put the sum of them together, you get the whole thing becomes much more efficient. So the record right now for commercial cells is held by a company called Solar Junction, which came out of some of the research that I did when I was in grad school. And Solar Junction basically does just this. They make a stack of multiple different solar cells, and they've gotten up to 44% efficiency. So 44% of all of the energy available in sunlight, they convert directly to electricity. So the other thing that's holding solar back is that the sun doesn't shine all the time. So what do we do at night or in the evening when the sun isn't shining but we still want to be able to sit down in front of the TV or make dinner? In fact, if you look at the energy demand, look at the orangish line in the middle, this 2 humped peak. This is the energy demand in California in 2012 over the course of a day. So noon is right in the middle. So midnight to 6 a.m. is this flat part in the beginning. So energy demand is pretty low. And you saw energy demand spikes as people get to work. They start turning on appliances. They turn on air conditioning. The factories are starting to spin up. And then at the end of the day, when people get home again, they're turning on their air conditioners, they're cooking, they're turning on TVs, and the energy demand goes up again. But once you start adding solar to the mix, solar actually kicks in right when you need more energy for air conditioners and factories and so on. So in California, actually, the energy demand started to plateau. In Germany, they actually have it go negative. So these are predictions for California, but in Germany this actually happened, where they had a day last year where the power company was paying you to use electricity for that day because they had too much power on being generated by their power plants, and they couldn't make it's too expensive for them to turn a power plant off and then try to bring it back online later. For a coal plant or a nuclear plant, that takes between 12 hours and 24 hours. So they don't do that. For a coal plant or a nuclear plant, they turn them on and they leave them on at the same power all day long. They might make some minor changes, but they really need it. They don't have a way to do this kind of adjustments with coal and nuclear. So right now what we do is mostly what we do, if we have a big solar installation someplace, we pair it with a natural gas electrical plant, which is not the most efficient, not the most cost effective, but natural gas plants you can turn on and off over the course of a couple of minutes. So natural gas and solar actually are a good pair for each other because natural gas is becoming cheaper because of fracking. Okay, that has other problems, but that's unrelated. That's a different set of problems. Natural gas and solar work together really well because the natural gas can fill in where solar starts to run for the variations in solar power. So we can also do things like storage. So you may not realize it, but part of our electricity that we buy benefits from pumped hydro storage. You guys know about hydropower, where you take water from a high level and then you run it through a turbine to a low level and you extract that energy through a turbine that drives a generator. Well, pumped hydro storage, if you have two lakes side by side but 1,000 feet apart, or at least a few hundred feet, you can drive them the other direction. So during the day, use this as a regular hydro plant, right? Take the water from the upper lake to the lower lake, and then at night, when electricity is cheap, drive it the other direction. So use your turbine as a pump and pump the water back uphill. So what we do in pumped hydro is we have two lakes and we just keep moving the water back and forth. When electricity is cheap overnight or when the sun is shining on solar panels, we pump the water uphill, and then when the sun isn't shining, we use it as a regular hydro plant to run it downhill. The other thing that we would like to do is if we had smart loads, like smart appliances, that would make a big difference in terms of helping solar power become more effective in our society, in our civilization. Because, for example, the utility, you pay the Indiana Power Company some amount of money. The Indiana Power Company is connected to computers that know what the forecast is, so they know when a cloud is about to move through town and all of the solar cells in town are going to drop in their power because it's now cloudy. So if the power company could talk to your fridge and freezer and say, hey, at 3 o'clock there's a forecast for a cloud, could you run early and cool yourself off so that from 3 to 3:30 we could just shut you off? If we could do that, that would make a huge difference in the effectiveness of solar power, because that means the variations that we have from weather would not affect the rest of the grid. We wouldn't have brownouts or blackouts, even if a cloud blows through, if the solar panels could talk to, if the weather forecasting could talk to your fridge and freezer so that your fridge could shut off for half an hour. Fridges can do that, that's no problem. They're designed to stay insulated for hours at a time. Like if the power goes out, you don't suddenly lose everything in your fridge, you have a few hours. And so, if we had a way that the fridges and freezers and other kinds of appliances could talk to the power company and be able to schedule when they are or not going to run, that can make a big difference in solar, because of that would help take account of the variability in solar. The other thing, of course, if we want to do storage, the most obvious thing is to build batteries. So why not store all of our power in batteries? The problem here is cost. As much as solar cells are expensive, batteries are way, way, way more expensive. If you wanted to power your house from batteries, you would need to cover this wall in batteries. Okay? Think about car batteries. It's so big, it's about $100. Now multiply that by the size of that wall, and that's how much money you're going to be spending for a wall of batteries to power just your house. Now think about doing that for a town or even just a suburb, and that's an awful lot of batteries, an awful lot of cost. And the batteries really don't have that much energy capacity. They're really not able to store that much power in a battery compared with things like gasoline. So this is the amount of energy that's stored on a battery as a function of size right, liters, and weight in kilograms. So you can see that your lead acid battery that's in your car, that's what starts your car motor, really doesn't store much energy for its weight or its size. One of the best things that's happened for solar power is laptops. Because once people started getting laptops, companies were willing to start investing a lot of money in batteries because you want your laptop to be working for more than 5 minutes. You want your laptop to run all day long. And so there's been a lot of investment in things like nickel, lithium-ion and lithium polymer batteries. So even though they're more expensive, they hold a lot more energy. And then even future batteries need to become even better. But we have a long way to go before we can compete with the energy density of something like gasoline or diesel, which we'd have to go upstairs to be able to see that on this plot. So batteries are way lower in energy density than fuels like gasoline, diesel, coal. So we have a long way to go before batteries can really be a viable storage mechanism, but it's the best that we can do. So if we can get batteries to be another factor of 5 more efficient in terms of the amount of energy they can store per dollar, then that would be a big win for solar power, because then we could store the energy that we're getting from solar cells and use it round the clock. So the politics of solar power are really interesting. So this is the third thing that's keeping solar cells from being adopted. And that's that utilities really hate you putting solar panel on your roof. They really, really hate it. And they will do everything they can to stop you, including getting laws passed to prevent you. Because that means they lose you as a customer. You're not paying them for electricity anymore. Okay? They lose money. Who likes that, right? So companies are going through a lot of efforts, some legal, some not quite legal, to keep you from putting solar panels on your roof. In Florida, for example, one of the sunniest states in the United States, it's illegal to put solar panels up on your roof. Why? Are they technically dangerous? No, not at all. They're no more dangerous than anywhere else in the country. They're safe, they're stable, there's no environmental problems with solar cells, but the utility has gotten the legislature in Florida to prohibit adoption of solar cells on the roof. So a lot of this is political from the utility companies trying to prevent you from doing it. And it has led to some very interesting politics. For example, you have libertarians who are sort of the far right wing of Republicans who are saying, what right do you have to say what I can and can't do on my land? It's my land. And you have environmentalists, the Green Party and so on the far left side of the Democratic Party saying solar panels we should be adopting solar at the cost of everything else. We should be completely supporting solar. We have these two people who normally wouldn't even talk to each other if they were in the same room, coming together saying, yeah, we should be able to do rooftop solar because it meets the needs of both of those groups and bypassing a lot of the people in the middle. So it's very interesting politically to see some of these cooperations that are happening from people who normally wouldn't even be talking to each other in order to help get solar established. So some of the myths about solar power. The first myth that you will hear people say is that solar panels take more energy to make than they ever deliver. And that has not been true since about 1970. So solar panels produce a lot more energy than it took to make the solar panel. And that was true even for common multicrystalline cells like the one that I passed around. They pay themselves back in energy in about 3 years. Modern cells pay themselves back in under a year. So you get way more energy out, like 5 times to 25 times more energy comes back to you than it took to make the cell. So there's definitely an energy payback. The other payback is dollars. So this is a little trickier because the myth is that you will never get your money back if you buy a solar cell because it costs more than you will ever get back in dollars. And this is half true, but for a very different reason. Because in this case, you need to have solar cells that last a very long time. And China is currently dumping a large number of really bad solar cells on the market. A good friend of ours back home bought and built a little solar array for their RV, and they paid a lot of money for it, and it lasted a year and a half. Cheap Chinese solar cells. They died early. So since all of your costs in solar, you're not paying anything for fuel. It doesn't cost anything to keep the solar panel running. You're paying all of your money up front. It's like buying the car with gas for life for free, right? You want to make sure that car is going to last a darn long time because you're paying the extra money up front. So in solar, you really want to make sure your cells last a long time because that's how you get paid back. If you do buy quality cells, which are others on the market, so you have to know where to buy, then you can get paid back even in states that are, average cloudiness, like Indiana, they pay themselves back in about 17 years. Places like California, which are really sunny, Louisiana, parts of Texas, your payback can be less than 10 years. So they pay themselves off in 10 years, and then you have another 20 or 30 years in which your electricity is completely free. So that's where your payback comes, is after they've paid themselves off in the first few years. If your cells last long enough, and they should be rated, a good solar cell should last about 30 years and probably last 40 or 50. We have solar cells that exist now that were built in 1960 that still exist. So there's no reason why you can't build a solar cell that lasts a good long time. You just want to make sure if you're going out and buying solar cells that you're actually getting cells that are from a reputable company that has been around for a long time and will guarantee their cells. So also, efficient solar cells don't necessarily have to be expensive. So like the cells that I make, with all these stacks of multiple different solar cells on top of each other, they're pretty expensive. But on the flip side is, it doesn't matter if it's expensive per square meter, because if it's efficient enough, you only need a little tiny piece. So take your 1 meter solar cell, like this one, carve it up into a bunch of little solar cells, and have that little solar cell receive the light from a big lens or a big mirror that focuses this much light onto a little tiny solar cell. So yeah, even though this was expensive per square meter, I'm only using a centimeter of it, a square centimeter of it. And so my overall cost is much cheaper because I'm concentrating light from using a large cheap mirror onto a small semiconductor. So it doesn't matter if the semiconductor is expensive because I'm not using very much of it. Instead, I'm collecting light from a large area. You can't see the scale. This is the guy standing next to the panel, the tower. So this is a huge installation. This would be something comparable to what a wind turbine would produce in power. There's another another type of concentrator out in the California desert, where each of these is individual mirrors that all just basically reflect the sunlight onto the top of this tower. So you put you put a relatively small solar cell up at the top of the tower, and you collect light over a huge area. So it pays off to have high efficiency cells that you can put at the tips of these where the light gets focused. The other thing you can do is you can do tracking. So if you have your solar cells facing the sun, that's where you're going to get the most energy, right? You're facing right at the sun because the sun you're getting the most possible light. If the sun is at dusk or dawn, I'm not getting nearly as much energy because I'm basically in my own shadow at this point. So if you could track the sun across the sky by putting your solar panels on a motor mount, then you can get something like a quarter more energy out just by tracking the sun like flowers do across the sky. So then the question is, okay, so if it's so successful, why all the bankruptcies? Part of it is that we as scientists and engineers have done such a good job that solar cells are now cheap. If you're selling something that's dirt cheap, it's harder to make money on it. Think about how many companies make millions of dollars selling bolts, right? Bolts are dirt cheap, so you don't make millions of dollars selling bolts. You barely make you barely cover your expenses. So it's been difficult for companies that were counting on being able to sell really expensive solar cells to continue in a market where solar cells aren't expensive anymore. So that's why a lot of these companies went bankrupt. Some of them had some really questionable financial and tax dealings also, which is why they went bankrupt. Most of these went bankrupt because they were also trying to use a technology that physically could not possibly succeed economically. So they were doing things that were fundamentally very expensive. Cylindra came in here at like $4 per watt at a time when other kinds of technology were already cost a third of what they were being able to even make their cells for, much less sell them for. So that's a good lesson if you ever are investing in something, like somebody says, hey, I heard my brother-in-law is starting this company, it's going to be great, you should get in on the ground floor. Go find somebody else who's really smart, who knows about that field, and ask them as a third party, is this ever going to work? And then get their feedback if it's a good idea or not. So in summary, solar power is here even without the subsidies. It's great in Hawaii, New Jersey, other places that electricity is expensive. What you really need are high efficiency and long life. Because these cells, if you're going to pay them, if they're going to pay themselves back, they have to last for decades. So you want to make sure that you're buying high quality solar cells. You're making good cells and that you're buying good cells. You need, ideally, you would like some kind of a smart grid so that your fridge and freezer would be able to know when the solar cells are about to lose power because they're talking to the utility is talking to the weather service and so on. so that you could have some smart grid where all the pieces are talking to each other. And then that would help. That helps with the variability of solar power. As clouds blow through, the rest of the electrical system can adjust. We also need, especially in the U.S., cheaper permitting and installation processes. We need to follow something like Germany's model, where everything is standard and cheap. And then storage would be helpful, but it's not totally necessary. If we had better batteries, that would be great. But even if we don't, we still solar generates more energy during the day when we're awake and using more energy anyway. So it's not necessarily completely necessary. So we have a few minutes left for questions, so I want to answer any questions you guys have.
You had said a lot of information about solar cells, some of which may have been over your head. The point that you need to get, what are they? How do they produce electricity? What are the pros? What are the cons? Just like you've been doing with everything else. If you don't know any of those, ask.
What's the pros?
The pros of solar power? It's free and it's clean. Those are the biggest. So you don't have to pay, unlike a coal plant, you have to keep buying coal. You have to keep mining the coal to keep it running. And a solar plant, the sunlight is free. So once you have built the solar panel, it's completely free after that. You know, maybe once a year you go off and you wash it off with a hose to get the dust off of it. That's about all you have to do. And it's clean. You're not burning anything.
Are all the cons like the installate, like all the money to installate stuff? That was all the cons, like the installation fees, all that.
Yes, the cost is really the biggest con right now. The fact that solar panels are still, including the installation costs and the building permits and all of that, that's still more expensive than coal. At least in Indiana, because we have cheap coal here.